Welcome to this lesson on using the periodic table and how we're going to use it. I don't want you to think that these are the only ways you can use the periodic table that we're going to do in this lesson. There are definitely other ways that we use the periodic table, and some periodic tables have more information on them than others. As you become more versed in um, chemistry and take more advanced courses in chemistry, there'll be more information placed on the periodic table that'll help you better utilize and better use it. But it's a very powerful tool, and it provides us with a lot of really useful information. Okay, so let's just go through the note and then go through some examples of how we can use the periodic table, and then I'll give you some a worksheet to as well to work on so that you can practice your skills using the periodic table. So each element listed in the periodic table is assigned a symbol, okay? And this is really important, okay, that you understand. Because the periodic table is got a lot of information packed into it, we can't simply write out the word for each one of the elements. Manganese is a long word to write out. And so fitting it into a small little box is rather challenging. And so they came up with a system where they said every element in the periodic table will get either one letter, and because there's more than 26 of them, we have to go more. So they one or two letters, okay? And some are one, like hydrogen is just H, and chlorine is Cl, and other elements, most of them seem to have two letters, but some of the more basic ones have one, which is kind of handy. Now, the first letter of the symbol is always a capital, okay? And it's just the nature of it. If you look at any periodic table, you'll see this very consistently. And the second letter is always lowercase, so it's not a capital, okay? That's the opposite of being a capital. An example is chlorine, as the example I'm going to use here, is Cl. And it's written with a capital C and a lowercase l. That's not a 1, it's actually typed in as an L, okay? And it stands for chlorine, okay? I don't know why they didn't use CH. I don't choose. I just live with what they are. And after a while, you become pretty competent at knowing what they are. I will get every year kids that will write chlorine as Cl like this. And this is incorrect, okay? You will be deducted. That's usually minor deduction, but you will be marked a little bit wrong if you put in capital C and capital L. There's no element in the periodic table that is capital C and capital L. It is capital C and lowercase l. And you might think I'm being a little bit frivolous here, but it is a consistency that occurs across the board. And so you might as well learn it right from the beginning. If I don't teach this to you or allow you to just write, whatever way you want, I'm only misleading you. And so I think that's important, okay? So each element is assigned an atomic number, okay? Now, the atomic number isn't just random. They didn't just pick ones anywhere they want. And because it is equal to the number of protons in an atom. So essentially, the atomic number and the protons are exactly. So you see, oops, didn't like me there. Scroll back to up. Put my mouse in here. Make sure I get my cursor in there. There we go. So atomic number is equal to the number of protons right here, okay? For any atom, that is true, okay? They're essentially the exact same thing. The atomic number and number of protons, always the same thing. An example that I'm going to use here is carbon has an atomic number of 6. Well, because it has an atomic number of 6, guess how many protons it has? It has 6 protons, okay? And so I've got you filling in these little key important words along the phrase here. The number of protons is fixed. That means it does not change. It cannot change. Every single carbon atom has 6 protons. I can count them. 1, 2, 3, 4, 5, 6. If I was to take one away, which I'm not able to, you're just simply not, but if we found one atom in the group that didn't have 6, say it had 5, well then it's not carbon. It's another element. it's the element that has 5 protons, which if you look at your periodic table, and I have mine open when I'm talking about the periodic table and using chemistry, I often do, I see here boron has 5. And if I was to add 1 to carbon, I end up becoming nitrogen. You change the actual substance that's there, okay? And so this is a pretty standard thing in chemistry, that it's fixed and it doesn't change. Now, I will hear every once in a while students, especially when we live next to a nuclear power plant, talk about, well, they change it out at the nuclear plant. Yeah, they do. I agree. But that is very sophisticated, very advanced chemistry, and it only occurs in very controlled environments, because the amount of energy that's released when we start splitting atoms, which is what they do up there, is phenomenal. And if they don't have everything, all their ducks in a row, we can have some serious problems. It's also what happens when we do an atomic bomb and we split atoms, and so we can have all kinds of problems associated with that. Under normal circumstances, that does not happen. Okay. So anything in our world that we see walking around on the streets, that is not going to occur. Okay. Now the periodic table also lists some other things. Okay. It also lists the average atomic mass. Okay. Now it's really important to understand this. It's average. It's not the mass of one. It's the average of all the potential atoms for that element in the whole world. So they've kind of worked it out and calculated what they believe the average is, and they write that down there. And it's usually something in a long decimal place. It's not usually a whole number. And that does not mean that all the atoms, or even any of them for that matter, atoms have an element of an atom have the same mass. Okay, none of them might have the mass that's written there, and it also means that not all atoms of a particular element have the same mass. Okay, and I mean, think of it this way: if I was to take the mass of every student in our school, or 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 classroom, whichever way you want, and I came up with an average mass of 67.42 kilograms, there might not be one student in the whole school that weighs exactly 67.42 kilograms. You're either going to be above it or below it, but you might not have any students that actually weigh that weight. So that is a possibility, and it's the same thing with atoms, okay? Now, we can find the mass of a single atom, okay? We can find the mass of a single atom. And it's usually calculated in what we call atomic units, or they give this symbol here. I just highlighted. It's kind of like a U, but sometimes that was the best thing I could find on the internet. Sometimes they make the U kind of extend up like this. Okay, that's terrible drawing on my behalf. But if you use like a italicized U, that's more than acceptable, or just a script cursive U, I'll understand what you mean by that. Okay, and you'll see me use that to represent the units, atomic units, not kilograms, it's not pounds, it's mass in atomic units. Okay, now the neat thing is one proton or one neutron has a mass of one atomic unit, and so all of our answers come out to whole numbers, so it's kind of nice that way. And yet you'll notice that most of the averages do not come out to whole numbers. Okay, so we have this thing called the mass of an atom. Okay, and the mass of an atom is represented right here. The mass of a specific atom is determined by adding the number of protons with the number of neutrons in the atom. Okay, and then we can get mass. So we can write this formula here, and it's like basically number of protons plus the number of neutrons. Okay, and this is a pretty powerful little formula when you're trying to find the mass of an atom. Okay, now for now, we're going to stick to looking at atoms that have a neutral charge. That means the whole atom, everything in it, there's an equal number of positives and an equal number of negatives. So that way we say that the number of protons then will equal the number of electrons. for a neutral charge, okay? So this is really important. The number of protons equals the number of electrons. They're equal to each other. And later on, we're going to look at atoms where this is not true, okay? But for now, this is how it will be. And it will be the electrons that we can change, okay? We can add and remove electrons. We can't add or remove protons, but we can add or remove electrons. So let's look at a few questions and see how we can use our periodic table to answer those questions. For example, what is the symbol for the element with the atomic number 12? Well, I don't know. I'm going to be honest. I don't memorize them by atomic number. Now, had they written in there, for sulfur, I might be able to tell you what it is, but I really don't know the answer to this as it stands. So I have to go to my periodic table, which I have open. And so I look for the atomic number 12. There it is, number 12. Okay, so just so you can see here, I'll open my pen and I'll circle the 12 right there, okay? And this little chart here tells me here, okay? So the atomic number is written on top, the symbol is in the middle, the actual name is here, and then the average mass is down below, okay? So that's where it is. So it's number 12. Well, the symbol for that is Mg, which actually stands for magnesium. So if I want to put that into my answer here, that symbol would be Mg right here. I'm going to just, because I know what's going to happen here, I'm going to get jumped around. M and G. And notice it's a capital M and a small g. That's standard. Okay. What is the atomic number for Cl? So that is chlorine. We saw that previously. And so again, I have to go back to my periodic table. I don't just memorize these things. Like, who has time to sit back and memorize a periodic table and know all this? Maybe somebody's working with it every day, all the time. Maybe they would remember it. Okay, so the atomic number for Cl, there it is, chlorine. And if you don't know, you just got to kind of scan your way through. We usually use ones in the top 54 here. I don't generally go down below that. I mean, there's plenty of options in here, so I will. And so chlorine, Cl, is right here, and the atomic number is 17. Okay, so I'm going to go back and I'm going to write that in there, right? Turn my pen back on, and I got 17. Si is the symbol for what element? Okay, so now instead of asking me what the atomic number is, they're asking me for the name of it. So I have to go back to my periodic table and go Si. I don't know what that is. Well, so I search through here and I look and I'm looking. Oh, there it is, Si. And if I can't see it, I got to zoom in really close. Maybe I'll bring in my scanner here. And well, I can just see it. It's silicon is what it is, okay? It is a little hard to read. These aren't the most detailed, especially when you're an old fart like me. It's kind of hard to see them. So anyway, that is silicon. So I can write that answer in. So turn my pen back on. Silicon. Okay? Now if you want, I could be just typing these answers in as well. That's fine. And then how many protons are in a carbon atom? Well, if you recall from the note above, the atomic number is in fact equal to the number of protons. So if I can find the atomic number, then I can find the protons. It's right there in your note. Protons and atomic number are exactly the same thing. So I jump back to my periodic table and I see if I can find carbon. Well, I don't need it quite this big anymore. I zoom back out. Well, there I can see carbon. It's in the second row and it's number 6. So that means there are 6 protons in carbon. Okay. So once again, I go back, I load it up, and I write my 6 down. You can see how if you're working with this in paper, it'd be nice to have a printed copy of your periodic table, but I don't have that handy in this format, so I'm using this alternate method. And then it is, what is the mass of a sodium atom with 12 neutrons? Oh my goodness, 12 neutrons. Well, I recall seeing here a beautiful formula that says Mass equals the number of protons plus the number of neutrons. I have 12 neutrons. So if I know how many protons, I can add them together and I would have my mass. That's not that difficult. So I just need to know how many protons, which is the atomic number of sodium. So let's go see if I can find sodium on the periodic table. Well, this is one of those really weird ones, and you got to look at all these words in here. It's going to be really hard, but I can go through it. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Oh my gosh, sodium right there. Can you believe it? The symbol for sodium is Na. I don't understand that one, but that's how they came up with it. I would have thought it'd be So, but So is not the option here. They just made it Na. And the atomic number is 11. That means I have to have 11 protons and 12 neutrons. And if I add those two together, I get 23. So the answer here is going to be 23. And if you want, I can write 11 plus 23. And that's protons plus neutrons. So positive protons, sorry, I should have wrote 12 in here. Plus the neutrons is 12, and that equals 23. Okay? My scribble is not very good because I got to write without putting my hand on the screen, and I apologize for that. And then it says, how many electrons are in a neutral nitrogen atom? Well, if it's neutral, meaning there's no charge, the number of electrons equals the number of protons. So all I have to do is find the atomic number, which equals the number of protons, which equals the number of electrons. It's not that difficult. So I go back here. What was the nitrogen was what I'm looking for. So I have to go through all these. Nitrogen is the 7th one right here. It'll take some practice. I'm pretty good at it because I have worked with the periodic table before, so it might show. So it has 7. So if you have 7 protons in your neutral, you would have 7 electrons. Okay, so put that number 7 in there as an answer. Turn my pen on first, and there it goes. And then how many neutrons are in a fluorine atom that has a mass of 19? Oh my goodness. Well, remember, I'm just going to write up here. Remember that mass equals number of protons plus the number of neutrons, right? Like that. Well, I know that my mass is 19, and I'm asked to find the number of neutrons. All I need, if I can know the number of protons, I can kind of figure out in my head here, I think, pretty easily. 19 is going to equal the number of protons plus the number of neutrons. So if I find out the number of protons, I think I can calculate the number of neutrons. Let's try this. So fluorine, let's find fluorine in here. Fluorine, oh my goodness, fluorine has 9 protons, 18.988. 998 is the average mass, okay? So 9 is the number of protons. So let's go back over here to our other page, and if I stuck in 9, and I say to you, I think most of you can do this in your head. 9 plus some number is going to give you 19. Well, what does that number have to be? 9 plus, and then just start counting. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. How many fingers do I got? I got 10. So I need 10 neutrons to give it a mass of 19. So what do? Write in the answer 10. Okay? And then I can create a whole unique class of questions on a table like this. Okay? And I'm going to go through these fairly quickly. I'll take my time, at least for the first couple. So the symbol is O. Well, many of you probably already know what the symbol O stands for, and it's oxygen, okay? So I can write the oxygen in. And I also know the atomic number is 8. So if I go back here, I can write in oxygen. Now I'm going to make my life a little bit easier here. And I'm going to write oxygen in here, and the atomic number is 8. Well, what's the number of protons? Well, it's equal to the atomic number. That's 8. Oh, it has a mass of 16, and the number of protons plus the number of neutrons has to equal 16. 8 plus what gives me 16? It's 8. 8 plus 8 will give me 16. So these two have to add to give me my mass. And if it's a neutral atom, always the number of, and they're talking all neutral here, the number of protons equals the number of electrons. There we go. We finished the first one. Then I can go to sulfur. They're telling me the name. I need to know the symbol. I don't know what the symbol of sulfur is, so I got to look for it. Well, I mean, sodium, that starts with an S. It sure would have thought that it had an S in it, but it didn't. So I have to look, and oh, here I find sulfur. And by the way, sulfur is sometimes spelt with a PH and sometimes with an F. I don't know. It's back and forth. This one here seems to show it with an F instead of a PH. And the symbol is just an S. The number of atomic number is 16. So that's important, okay? So I come down here and I say the atomic number is 16. Oh, turn my thing on, 16. The symbol is S. The number of protons is 16. The number of neutrons is 17. So therefore the mass would be adding these two together. If you can't do that in your head, you're going to have to get a calculator. I'm pretty good. I can do that in my head pretty easily. 16 plus 17 is going to be 33. And then the number of electrons is always going to be equal to the number of protons. So in this particular case, it's 16. This is because it's a neutral charged atom. We have to have a balancing competition between electrons and protons. They have to be equal. Then I can go to the next one. Oh, it tells me the atomic number is 20. 20. Okay, so let's try this one here. Go atomic number 20. Well, this is easy. Just keep going across. Oh, there we go, 20. That's calcium. Okay, Ca is the symbol and calcium is the actual element. So I come back here, turn my pen back on, calcium, symbol is Ca, and again, big C, small a, okay? The number of protons is going to equal the number of atomic number, and it happens to be that the number of neutrons is equal, and so we add these two together to get our mass, which is 40, and our number of electrons is always the same as protons if there's no charge, okay? So that gives me 20 here. We got 3 more to do yet. Let's try iron, okay? You've all heard of iron before. Well, where's iron on the periodic table? Well, it's another one of these ones that has a weird symbol for it because I think it's more Greek based and it's right here. It's iron is Fe. You might have heard that before because iron is a pretty common substance in our world. Some people are low in iron in their blood and they need to get it, and so they'll sometimes see that Fe symbol. Okay, and the atomic number is 26. Those are the 2 bits of information I need to fill this chart out. So the symbol is Fe, and the atomic number is 26. Therefore, the number of protons is 26. The number of neutrons, oh my goodness, now I'm in trouble. I've got to add 26 to something to 26 to get 55. Well, I'm going to give you a little trick here. If I take the 55 and I subtract 26, that'll be the number that I need to fit in here. And if you do that math, I think you're going to come up with 29. Now, another way is just pick a number that you think is close. You could put 26 in and go 26 plus 26 is 52. That wasn't big enough, so I had to go 28 and then 29, and you eventually get there, okay? So 29 neutrons in this particular case. And again, the number of electrons with the number of protons will be equal if we are a neutral charge. So this is going to be 26. All right, the next one is number 29. Number of protons is 29. Well, if the number of protons is 29, that means my atomic number has to be 29. So now I can go to my periodic table and look this one up, okay? Oh, here we go. 29. Where are we? Oh, there. Cu for copper, okay? So copper is Cu, and it is element number 29. So come back over here. I write copper in like that. Capital C, small u. Okay? And then I've got my atomic number. I've got my number of protons. I need to find my number of neutrons. And just like I did up here, I can kind of guess numbers until I get there. But I mean, in the end, the answer is going to be 35. And I do that by taking 64 and subtracting the 29. And that's pretty basic mathematics of solving an equation. For some of you, that might be a bit of a challenge, but if you practice it, it's not that hard. When you're trying to find the neutrons, you just subtract the number of protons from the mass, and you will end up with your number of neutrons, okay? Now, the last one, of course, number of protons, number of electrons is going to be equal, so this will be 29. That's because the charge is equal, so it has to be. And then we have our last one, Br. Well, whoa, how do I do that one? Well, let's look at the periodic table again, and we look for Br, and you scan through until you find it. Oh, there it is, Br, right there, okay? Atomic number 35. That's all I need to do is I remember 35 and Br, and I can go back, put my atomic number in, and write bromine. Oh, I didn't state that before, but Br is bromine. And it's funny how, that's nice and easy. Br kind of connects to bromine, but Cu, there's not even a U in copper, but yeah, hey, I don't make the rules. I just play by them. And then down here we have bromine, 35. Number of protons will be the same as the atomic number, so that's 35. And then when we add these two together, we get our mass. That will be 75. And then finally, the number of electrons will equal the number of protons. So it is 35 because it's a neutral charge. All right, I've gone through, 6 of them here. I'm going to give you on your worksheet, you probably have 10 or more plus some questions like above. So give it a go. And practice understanding how to use your periodic table to gain some relevant information. Hope you've enjoyed the lesson, and we'll see you next time.